All right, thank you. So they're asking us to find the direction and the magnitude. Now, you guys can see this is written as a linear combination, which I know for many of you last class period was something that was kind of still a little uneasy, right? Maybe it didn't all fully click. So one thing I just want to remind you guys is when you're doing problems like this, remember, we can always rewrite these in component form. Right? Linear combination and component form are interchangeable very, very quickly. So while you're still kind of getting used to this I and J linear combination, write in component form very quickly. All right? So if I want to sketch this, we didn't say to sketch it, but I just want to sketch it because I want you guys to be able to kind of use some visual representation here. They're asking us to find the unit vector and the direction. So we need to know a couple definitions, or a couple formulas. First of all, if you guys remember, the unit vector u was basically the vector w over its magnitude. That was our formula. That was our definition. First thing we have to do is find the magnitude. Well, how do you find the magnitude of a vector? If you guys remember, the magnitude of the vector was what we did last class period with that distance formula, right? But instead of having to subtract them, we already have a component at 0, 0. So we can just do w1 squared plus w2 squared. So in this case, I have 5 squared plus, or negative 5 squared plus 5 squared equals 25 plus 25 equals square root of 50. If you guys remember, simplify the radical. That's 25 times 2 equals 5 square root of 2. Does everybody follow me with finding the magnitude? The magnitude is the length, right? And would you guys agree that if I was going to create a triangle on this, 5 squared plus 5 squared equals the length of that, right? That's basically just what I did with this formula. But you guys want to know this formula because not always are you going to need, not always are you going to want to spend the time to graph it so you can get that visual reminder. So our magnitude is 5 square root of 2. So u equals our vector, negative 5 over 5, divided by 5 square root of 2. Ugh, this doesn't really look that fun. Now, remember last class period, I did show you how you could rewrite that as a product, right, as a fraction? Yes? Or just distribute all the way in. And therefore, we get negative 5 over 5 square root of 2, comma 5 over 5 square root of 2. My unit vector is now equal to negative 1 over the square root of 2, comma 1 over the square root of 2. Do not need to simplify. We'll leave it just like that. Is perfectly fine. All right? But then they want us to find the angle. Now, this is really, 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 really important. Whenever you're asked to find the angle, please draw the vector. Until you get really used to this, draw the vector. Because, guys, do we have enough information to find this angle here? Yeah, this is right triangle trigonometry, right? Tangent of theta equals w2 over w1. So therefore, to find this, I'm just going to use theta equals tangent inverse of w2, which is 5 over negative 5. So I just make sure my calculator is in degree mode. It is. And I'll just do tangent inverse of negative 5 divided by 5, or 5 divided by negative 5, which is negative 1. And I get 45 degrees, which actually I should have known that. If I was going to say, hey, come and pick me up at negative 45 degrees, standard position, are you going to come? Are you going to go to this vector in the second quadrant? No. So the way that we represent vectors, unless we're talking about navigation, the way that we represent vectors is in standard position. So we want to use this angle theta. Now, is this still 45 degrees? Is this angle theta still 45 degrees? Yes, it is, right? Oh, it's negative 45 degrees, but that's because the domain of tangent is restricted. It really is 45 degrees. But we're not looking for that, 45 degrees. We're looking for this, and that is 180 minus 45, which is 135. So our angle theta is 135 degrees. So you're going to have to be careful on your quiz and eventually on your test. It's going to ask you to